from the command center of the jwsolarusa live from Minnesota. Guys, another update for my Nissan Leaf batteries, and these are 7 modules, wire in parallel, 7 in parallel in series. If you haven't seen the videos, I want you to go back and check into this system and see what I've done. And I already used this. I covered that in my last video. I used one of these water pipes stuff for hot water, for copper, from the hardware store, and to cover my terminals here. And I just improvised. I talked about it last time. The copper is just like a shelf thing, drawer, but I improvised this. It's on the hardware store as well. Was a heavy duty. I cut it, if you see, and to cover the center taps. I've done this without you guys. I hope you guys are okay with that, so you can see what I've done. Get all the batteries, the center tap, so that I can have full potential of this battery. I can able to draw anything I want. It's compressed, and I have a 2 hot cable here. And let's go back to the inverter. Back to the system. You see from the wire, the negative, neutral, whatever, is coming to the negative part of the shunt, smart shunt, Victron smart shunt, and this is how it looks like. And it's coming from here and distribute the power equally to all the component, and comes to the bus bars, negative bus bar, and the positive direct from the battery. It comes all the way. I'm gonna put another disconnect here somewhere to just isolate the batteries completely. And it comes to these bus bars. From the bus bars, it comes to the disconnect. So disconnect is for the number 2 is for the charge controllers, and we are now on float. So we're about to do a full capacity test on this system. And if you put on 1 is the inverter, and inverter is off right now. This is the Victron Phoenix Inverter Smart. Is a 12 volt 2000 VA, built with the Bluetooth capability. And so as these guys here, the Smart Charge Controller MPPT 15045 with the Bluetooth capability. You can see that here. So that means I can able to see that on the app, on a phone or tablet, which we're going to be doing right now. And this side is set up for another set of panels that come here is the 100 volt and 20 amp, the Bluetooth capability. And this one has a load. Can able to use a load here, DC load, for lights or relays or whatever. And this one doesn't have it. So it has the VE cam, Victron Energy CAN bus over there. So, and I have my GFCI already created. Here is a 20 amp up to 125, 20 amp. And we're gonna initialize this guy here by turning this switch to 1 and 2. Or I can turn it to 1, just the inverter, then the charge controller shut off. Okay, so you can see it's gonna initialize, then it's gonna go off. Now it's on, it's ready to go, just like when you have something on standby. Till I push this button right here, the mode which I want is the echo, and the alarm's gonna be showing here, or the full inverter. So echo is just gonna be searching for load. So what we're gonna do now, the power is already on that guy right there. So this is the 5.5 kilowatt inverter made by Diamond Series Voltage Converter. The model number is DSR-5500, so 5.5 kilowatt. And you can tell us the voltage here. It's going to be on 230 in, and it's going to give us to 120 US, North America. So now I'm going to incorporate this guy right here which is Asus tablet, and we're gonna initialize the app, the Victron Connect, and Victron Connect is gonna connect to our devices here. Now it's gonna find all of them. You just saw that. Okay, so this is the inverter, and this is the shunt right here. I talked about them, and these are the two charge controllers. They are floating right now. So what we're gonna do, if we turn this guy here, it says we're 100% still to charge. So what we're gonna do, we can, you see all the parameters here. You can do this. What we're gonna do, we're gonna reset this guy, the shunt. We make sure that it's 0 out so that we can tell our capacity. We're doing a capacity test. So what I'm gonna do, I'm gonna push this guy right here, the reset history. Yes, everything's gonna wipe out. We just did. Now the inverter is on. You can see the green light, and the charge controllers are still on float. It has so much function. These are all the functions on the inverter, and we are pulling only 6 VA volt amp. So now what we're gonna do, we're gonna power up the transformer. Watch this, it's gonna disconnect. The power is dropping 14, almost 1500. I can able to show you the spike that happened on the shunt when we connected the system first. You can see the spike right here. You have two lines, one's for the amps, and one for the red is for the amps, and the blue is for the volt. Running a constant voltage, the amps are up. So the water is gonna boil. I want you to see this. Oh, I don't want to miss that. Let me open it. You can hear the water. Let me show you. It would have shut off already, but I opened the cover. That's another technique. If you open this cover, it's not gonna do the automatic shut off at all. The water will continue boiling, just like having a saucepan, like cooking something. So it's not gonna go off. So the mechanism is on the cover. So watch this, and I'm gonna shut the lever. There you go, pops. As soon as you shut the cover, the lid, and it shut off. So this gives us the test that we were looking for, and the inverter didn't pop, and it was just running constantly, the fans. I don't think we're gonna be running this inverter constantly like what we did on this kind of load, because this inverter, this setup is going overseas, and it's gonna be doing an awesome job, because international voltage we have here. The batteries are fine, they're doing pretty good, no problem. To the shunts, power transfer, nothing. This wire, nothing. This is the one that was getting warm the last time, so I changed this one to number 1 AWG. And these guys are 2 hot cable from the batteries, and I think this one goes to the charge controller, sorry, the inverter. I think they are 8 gauge. Due to the inverter is just a 2000 volt amp, which runs approximately the max of 1600. So I was checking on the the bus bars here. On this wire, I was telling you guys, a 2-gauge wire that transfer the power from the charge controllers and all the way to the buses, and it takes the power back from the bus bar and direct to the charge controllers and the inverter as well. So I gotta beef up this wire right here. I felt a little warm, and the stud underneath here, I was feeling a little bit warm. Okay, it's another one here, which mostly is the one back here. It's still a little bit warm, so I might probably change maybe 2 switches here, but I like this setup. So just transferring the power from this wire coming to the bus here. That's a little bit strenuous here. That's a kind of resistance. So I'm gonna beef up this wire. I already planned to do that. I did plan to do that, but I was just testing this, and now I'm using that load to check, and everything is fine. Charge controllers are flashing. Fire it up one more time just to make fun of the system. So this time I'm gonna give you a glance how everything is running here, since you don't have the chance to see that right there. I cannot hear this fan running at all unless there is something really big, like almost maxing up the inverter. That's the time we're gonna be having that noise coming out. The breaker didn't trip, and the water is boiling. There we go. Water dropped. Thanks for watching. Love you guys all. JwSolarusa, live from Minnesota.